Good afternoon, everyone. My name is Richa Gupta, and I'm a PhD scholar at the Indian Institute of Technology in India. So I would like to begin by talking a little bit about my lab, the team of which I'm a part. So it's the Assistive Lab at IIT Delhi, and the team is involved in developing assistive technology solutions for the blind and visually impaired for over a decade now. And the team works mainly in three areas of mobility, solution, navigation, and education. And in the domain of mobility, the lab has created a smart cane device. It's like an ultrasonic obstacle detection device, which helps visually impaired individuals in their mobility. And in terms of navigation, we are in the process of developing a bus identification system, and we have been testing this project with government buses. So it's a two-part device. So one is installed on the buses, and the other is a very small handheld device which is given to the person with visual impairment, and they can with just a click of a button, they can know what buses are there in their vicinity, like the number, the destination. Because we also, like here in Stockholm, we also have the bus with only the LED display scrolling on top of it with the number, but it's very difficult to know for a visually impaired person what's the number of the bus. In the realm of education, we've been working to develop a refreshable and affordable refreshable braille display, TACREAD, an interactive tactile graphics generation tool, so which will be accessible, so teachers themselves can create graphics for their students. And last but not the least, the design and production of affordable tactile graphics. So I want to take a minute and mention a very important aspect that our lab takes care of, because we are developing solutions for India. As you all may be aware that we have the largest population of visually impaired people in the world, and in order to and most of these solutions you might be thinking that are already available in European and American countries, but the fact of the matter is they are very expensive, and to bring them to a big population in India, it becomes difficult for the individuals themselves as well as for the government. So a major aspect which we have always considered in developing solutions is affordability, with not compromising on quality, of course. So all these projects and products are affordable, and that's one of our main aspect. Yeah. So I'll talk a little bit more about design production of tactile and affordable tactile graphics, because that's the area on which I am working. So let me mention, as we have been listening to all these presentations since the last 3 days, I think I don't need to justify the need for accessible graphics here. I think everybody knows it, why we need it. So, but I would like to just mention a few points, why, when in the absence of accessible graphics, what happens, and why is it like brings the urgency to bring the graphics to the students. So as we can all say that the lack of access to graphics impedes subject learning and understanding course content, and which eventually leads to abandonment of science and mathematics subjects by this time students reach middle school. They leave these subjects, either switch to humanities or just literature, something like that, and that actually excludes them from many vocational and academic opportunities, because as we are moving more and more towards technological developments. A lot of fields of vocation as well as academics are related to science and mathematics. So of course there is an urgent need for tactile graphics in the world. So, in the keeping the same thing in mind, a Center of Excellence in Tactile Graphics (COETG) has been established in IIT Delhi. It has been sponsored by our ministry, Government of India, Ministry of Electronics and Information Technology. So, with the objective of making diagrams accessible and affordable, more importantly, for students with visual impairment. So, there are a few activities in which we are engaged. Development of affordable technology for production of tactile graphics. So we have developed a process with which we can develop tactile graphics, and the end graphics cost almost 1/20th of a swell sheet. So which is okay for India, right? So So, and of course they are they are plastic sheets, so they are more durable and thermoformed, of course. And currently we are developing, like translating a lot of tactile book science, maths of middle school classes in collaboration with NCRT. So NCRT is a body in India which actually designs the curriculum and textbooks for school students in our country. So that's what we are doing. And we are also engaged in user testing and getting feedback on effectiveness of tactile graphics. Also training and sensitizing educators on the need and use of tactile graphics as well. So slowly we have, like till recently, tactile graphics was a very new thing in India, and now we are like spreading it to more and more teachers across the country. And of course the team, I am sort of engaged in the in-depth study of tactile guidelines and research on comprehension of tactile graphics. So I would like to share some of my some of the recent research directions that I've been exploring. So I would like to put in some groundwork for now. As was also mentioned by Professor Erickson in her presentation, that a lot of research is there, literature is there, which is actually addressing, dealing with tactile perception of textures, forms, and the semantics. That is shape recognition or form understanding and texture perception. But very little research is available which actually deals with contextual diagrams. And by contextual diagrams, I mean diagrams which are there in textbooks. So, and because most of the literature actually use abstract stimuli for experimental purposes, and that is why I asked Kim regarding this, how does she actually takes care of biases, because there are a lot of biases, and I think she would agree, when the moment we go into a contextual diagram and we want to test it and sort of draw conclusions from a study. So, but when abstract stimulus is used, drawing conclusions is much easier. But because there is very less studies, less literature available, which is actually dealing with contextual diagrams, the understanding of effectiveness of tactile diagrams or graphics in education still remains unaddressed. There are a few works happening around the world right now. So again, so one of the major reasons for not addressing the contextual diagrams is that the moment we put context in diagrams, it becomes complex. It is very difficult to work with in experimental scenarios. And but different design elements and attributes actually need to be studied so that we actually understand how to put how to use those elements the best way in order to communicate the pictorial information that is there in the graphic. So as we are all aware that most tactile graphics are only outline drawings, raised outline drawings, but outline drawings are very limited in their ability to represent pictorial information and communicate pictorial information. Even for, you can imagine a picture without color, without any perspective, without any shading, just outlines, just comprised of lines, and it sometimes becomes ambiguous, and it's very difficult to extract meaning out of only line diagrams. And so is the case with our visually impaired students. So it's very difficult for them to extract meaning out of only outline drawings or just accompanied by textures. So I have selected one of the major kind of graphics that are used in our day-to-day activities, as well as one of the most important elements in educational purposes. So what is the intent of statistical diagrams? What is the intent of statistical diagrams? They are meant, so this data which is represented here in a bar chart was actually some tabulated data, right? So, but when it is put in this pictorial illustration, it becomes easier for us to get an idea about the trend in data just by looking at it for a second, just with a glance. But that doesn't happen for the visually impaired people. And these kind of illustrations make reading data more intuitive, right? But these kind of diagrams have a lot of elements in them. So bars, the axes, numbers, labeling, a lot of things. And it's challenging to be perceived through tactile perception. Maybe if given time, they're able to do it, but the kind of intuitiveness and getting an idea with a glance is not happening. So this is a picture of a diagram made with using the BANA guidelines, the Braille Authority of North America guidelines, with lines and filled textures, axes, grid lines, all those things. But they, again, they are only outline drawings, and it becomes, there are a lot of design elements in one pictorial representation, and it becomes very difficult and challenging for a person with visual impairment to understand it in little exploration. So, and guidelines sort of fall short in cases when we are talking about complex information. So the guidelines tell a lot of things about layouting, simplification, what textures to use, what kind of line types to use. But the moment we go into very complex scenarios, they fall short at telling a lot of things. So what I proposed was using varying height in tactile diagrams, tactile graphics, as a quantified attribute in complex diagrams. So height is varied in steps, and every step depicts a value. Height increases with the value of the entity depicted, and this hopefully is more intuitive, and the observer, the reader, will get an overview about the trend in data with little exploration. So I'll just hand out a few examples that I have. So I request you to pass these in pairs, so you can get an idea, compare the two kinds of diagrams. So one is according to, is more an outline drawing or textures according to the BANA guidelines, and the other is what I am proposing. So here are the few. These are the diagrams that I have circulated. So this is an area chart. The left picture shows the line and texture version, and the right one shows the height version. Similarly here, the pie chart. So I tested these diagrams with middle school students, and there were 14 participants in the age group of 13 to 18, and I gave them both kind of diagrams, and then some questions were asked in reference to the context of the diagrams. And I can't go into the details of a lot of experimental things, but this was a general percentage accuracy of the responses that I got, and the pink bars are for the texture or the line diagrams, and the orange bars are for the variable height diagrams. And clearly, as you can see, that the percentage accuracy in the responses that they gave is much higher in case of height diagrams. So there were few observations during the study that the participants were able to give more correct answers with variable height diagrams, and they could comprehend the diagram more easily and in lesser time. And when I asked them to pick a favorite diagram, almost all of them picked a height diagram as a favorite. So this method actually gave them an overall idea about the trend of the data with little exploration, like we got in a glance. So if they wanted to go into the details, they can go along the axes, read the numbers, get an exact idea of which is highest, which is lowest, what are the values, etc. But to get an overall trend, this was more effective and more intuitive. So to conclude, I would like to point out a few things which I'm planning to do ahead, and any suggestions are welcome because I'm just starting my research. And so I'm hoping to explore more like variable height diagrams in other contexts. So, and I would also like to understand the limitations in variable height. So for example, if there are two steps, what should be the minimum difference between the two steps so it is discriminable easily, and hopefully establishing the advantages of using it as a design constituent in tactile graphics, and creating an affordable production process, because these are made with a different production method than the earlier diagrams. So so this is like in the way ahead of trying it in another context. So this is a diagram of a map of India with annual rainfall. So I tested these also with the participants, but the results were so drastic that I didn't put it in the graph that I showed. In this diagram, they were not able to understand anything at all in the left version, the texture and line version, because as you can see, it's very complicated. But the moment I gave the other diagram, so every area represents the amount of rainfall in that region, and the areas that receive higher rainfall are higher, and similarly the areas that receive lower rainfall are lower. So that was very intuitive, and they were able to tell a lot of things in that diagram, but this one they were not able to give even a single correct answer. So yeah, so difference was so drastic that I thought it would look like as if I made it up. So yeah, so if you want to know more about our work, you can visit our websites, or you can get in touch with me at my email address. Any suggestions or questions are welcome. Thank you.
So, thank you very much. Very nice talk. Are there any questions?
Are there any?
There is a question down there, I think.
Hello, thank you. That was very interesting. I was wondering, have you considered using 3D techniques to do those heights? Because it seems that very soon you need to have a lot of height, so I think it might be easier maybe than the traditional vacuum form of.
So actually, are you talking about 3D printing?
Yes. Yes.
So these diagrams are made using 3D printing.
Okay.
The mold for the previous ones, the mold was made using 3D printing in our lab. But this is something which, if you had the opportunity to touch one of these, I wanted the surface to be smooth and no texture. You can't get it in 3D printing. There is always this thing. So I have used. I've made the mold for this using laser cutting and a lot of hand craft, I would say. So right now it's like more in a prototyping stage. So once I think right now I need to establish whether this is more effective than this, then the production thing can actually come up later. Yeah.
I think I thought I saw another hand somewhere. And I'm just following up on that because I think I saw, because I mean this with the height is sort of comes in the 3D print studies also. 3D, so there might be stuff to look at also.
Yeah. So I have actually, I tried it in making with 3D printing at first, but the results were, the resolution and the result was not as impressive. So I kept trying in different ways. I used cardboards, I used plastic sheets, I used several kinds of material, and this was like eventually the way I got a good result. So I kept on doing it.
Did you also try, because I noticed for the braille, it actually makes a difference which way you orient it when you print it. You get very rough braille if you print it flat, whilst to get the smooth braille, you print it standing.
For braille, we don't use 3D printing. For braille, we use...
no, but I meant for like your structures might be smoother if you orient it, maybe if you print it high on the height instead of the low. I don't know, but it was just a question.
Okay. So actually these are like thin plates, so it cannot be printed like vertically. So it has to be printed like this if you are going for 3D printing. So yeah.
Okay. Are there any more questions?
Any more questions?
No? Then we thank you again.
Okay.